The coronavirus dashboard was essentially a initial idea that was proposed and started by the head of public health data science at PHE back in early March. Julian Flowers is the person, and at the time, it was felt that there is a need for a service of this nature, and the initial service that was presented was a simple map with a couple of metrics, namely the number of cases and number of deaths on a daily basis. And later in March, NHSX, yes, commissioned a service to an external provider who designed it, and then just before it was ready to be deployed, it was passed on to Public Health England, and that's when I got involved. That was about 10th, 11th of April. And then the first version of the official service, not the map that was on ArcGIS, the actual service was launched on the 14th of April. And it's been running ever since. At the time, we started with only 4 metrics and the map. And right now, we have a few more metrics as well, so we'll get there. So let's go ahead. This will be the running order of the talk. So where are we and how did we get here? I'm including a quote here from David, who just introduced me, which I found very interesting in one of our correspondences, and I asked him if I could include it here. So this is about the swine flu epidemic, which, at the time, we didn't really have access to real-time data or near real-time data. And it was quite difficult for both people and decision makers to make sense of things because the data and the information wasn't really consolidated. If you needed data, you needed to go to different organizations, and request the data, wait a few weeks to get it. And by the time you got it, it was probably a few weeks old. And even then, you would have to, do a whole lot of work to make the data consistent, because you wouldn't be getting it in a consistent format. And that was an issue for a lot of organization, people, decision makers, and so on. So to see, how we got here, we need to know where we are. And this is where we are, or an overview thereof. We have approximately 750,000 users a day on average. Some days we have 1.2 million, some days we have 700, but usually not below that. And number of weekly users, again, on average is about 2.5 million. We have 80 million page views a week, 45 million daily hits, 1.3 million daily downloads. So that includes different types of data in different formats by different means. And at 4 p.m, and we release the data every day. And by every day, I mean literally every day since we started. We have up to 100,000 people on the website. Now, it wasn't always 100,000 people clicking refresh, trying to get the data. No, it started back in April by about probably 2,000, not more than that, if that. And it just gradually increased. It had a sudden surge in early summer, then again in midsummer, then again in October, and then again in November. So we had about, an increase of about 20,000 at each of these points. The presence and availability of this data has in a sense encouraged and and increased people's interest and engagement with quantitative measures and information, and in general data. People who are not necessarily scientists, are not necessarily familiar or comfortable with data, have been using it to make important decisions in their daily lives. This is something we'll get into later. So initially, as I said, we started with a very simple version of the website with initially 2 metrics, then it was 4 metrics, plus the rates and a very simple map. Then we moved forward to the second version of the service, which was launched immediately after the daily press conferences by the UK government ended back in late June. So they ended on the 26th of June, if I'm not mistaken, and we launched this service on the 27th of June in beta mode. It was partly, in fact, that the fact that they were stopping was a factor in the design that we used to create the second version, which is why these content that you see on the website, even now, look slightly like slides and cards. They were trying to kind of imitate what was being displayed on national TV to people, so as to reduce inconsistency and help people get more comfortable with the general concept and the data in general. And this is a version that's currently online, which you can see on the website. Now, the daily process of getting this data is not as simple as a whole lot of people seem to think. Now, I'm engaged with people on a regular basis by social media, try to communicate with them, hear their problems and help them. And it was very interesting that at first a whole lot of people thought that we were using Excel to provide this data. So many people thought, well, how difficult can it be? You're just entering a couple of new numbers in a spreadsheet and just put it online, and that turns into the website. Well, the general thought still exists, but it is changing. And that's probably no small part due to the fact, otherwise known as the Excel gate, that we had back in October, that there was an issue with an Excel spreadsheet that caused the number of cases to be underestimated for a few days, which was not at all related to the dashboard. It was related to an upstream source, but yeah. So this is an overview of the daily process, in that we start at 8 a.m. every single day, and at that point, the processing of the data that have been submitted and are supposed to be released today, if you like, start. So essentially, there is a cutoff for number of cases, for instance, and they get submitted at around midnight. And at 8 a.m. we start some of the processes to get them ready for release. Now, concurrently, there are some manual processes that include, gathering data from different sources, doing certain analysis, entering certain parts of the data into a format that can be ingested by the pipeline, and even we might find it very difficult to believe, but in some cases we have to just go to the website of some of the devolved administrations and quite literally write down the numbers, because we don't have any other means of getting the number. And yes, this process continues until around noon, at which point we get the MSI data file. The MSI, for those of you who use the website, are these small areas defined by the ONS, and that have about 8,000 population in their boundaries, so statistical boundaries as opposed to administrative ones. Yes, so that data is submitted around noon and it starts getting processed. It's quite a lot of data. I think last time I looked at it, about 3.9 million records, rows, sorry, not records, rows. That would be multiplied by 4 if you want to know the number of records. So yes, that starts getting processed, and then we receive the demographics data. So that would be cases by specimen data and deaths by date of death, data at around 2:30. That gets processed, and then we go to the main data. So these are not placed, arbitrarily. That if things overlap, it means that they actually do overlap the processes with each other. At around 3 p.m., we get the main data. And then, so that is a process that's done on a daily basis. So this part processes about 600 to 700 million records to produce these 3 files each day. Then we move on to the ETL. ETL stands for extract, transform, load. It's a service that we design in data engineering and computing to handle data, usually larger volumes of data. The ETL does some pre-processing on the main data file. So the availability of the main data file is what triggers the ETL. So these two are supplied, they are processed separately, but the main data file, when it is available, it triggers this process. So there is some pre-processing done, then we do some calculations that take about 4 or 5 minutes, and then we start the process of deploying the data to the database and to our archives. So that takes about 16 to 20 minutes. So if things go exactly according to plan, and I probably can count the number of times that they have actually gone exactly according to plan on my fingers, we should be ready with the data and be in a position to start the final QA process at around 3:30. But that almost never happens. So it means that we are always delayed, because usually one of the 26 sources that provide the initial data for our service are delayed. That's the usual reason. And that means that this time frame is pushed forward. So 3:30, 3:40, 3:45, whenever we're ready, it takes about 10 minutes to do the QA, and we have to release at 4 p.m. So again, these are not, overlapping accidentally, because sometimes we don't have enough time to do a full QA. So we continue to do the QA even after we release the data. And if you find something that is particularly worrying, we might remove the part of the website that is showing it until we correct that. If we find that it is not so worrying, we might note it or deploy a banner to that effect, or inform people that we have spotted a problem with that. The problem here is that this process, each of the processes involved in the pipeline can take anything between half an hour to 2 hours, 3 hours to run. So if there is a problem, say in the cases that we notice in our final QA, we have to go back, correct that, if not from the source, then if we can correct it manually, we correct it manually in the pipeline, and then run the pipeline, which takes about an hour and a half, 2 hours to run, then do this whole process over again. By that time, it's 6 p.m. So that is the reason why we are sometimes delayed. And it's one of the, I suppose, side effects or perks of having to release data near real time, we do understand that it is frustrating for a lot of users and a lot of people, but there isn't much we can do about it, unfortunately. These two processes, this might be more interesting for people who do technical work, but this is my attempt at creating a Chinese wall. These two processes are entirely independent of each other, in part due to ensure security and prevent accidental leak or disclosure of data, because this part of the service contains sensitive information or granular information that can be personally identifiable. This part of the service will never contain anything that can cause such issues. So the volume of data is what brings in the complexity, in that have 26 sources I mentioned, 600-700 million figures are processed to produce 8 million figures that are then pushed into our ETL service. And our ETL service does additional processing. It produces about 45 million figures, and all of them go into our database. So you can see that as of the 16th of February, we had approximately 2.8 billion records in our database. That's a massive, massive volume of data. And every single one of these are available on demand to people by different means. So they can download it and do whatever they want with it. You can download the data as it was published in September 2020. We do publish all of the time series every day, but we might make corrections, we might make adjustments. But if you want the data as it was released on a specific day, you can even get that. Now, talking of complexity, this is our pipeline. So these are different, each of these colors signify a different type or category of data that is being processed to produce the final output. And if I go further, you can see this is the SCSS source that produces England cases. You can see this is just to produce cases by specimen date for England. Now, moving on to ETL, this would be the structure of the ETL. So once data are pushed to our ETL service, we split them into a whole lot of jobs so that we could deploy a distributed computing infrastructure, which uses up to 90 computers simultaneously to process these figures. Otherwise, we'll be here for 2 days to get them done. So yes, these are the numbers, and these are not arbitrary numbers. So the MSOAs, we have in fact 6,800 MSOAs, or we have 1,115 combinations of area codes in England, Scotland, Northern Ireland, and Wales, and so on and so forth. So they get split into a whole lot of jobs, let's put it that way, and then a whole lot of processes are done that include suppressing parts of the data and ensuring that we are compliant with information governance policies, generating reports, submitting reports to certain bodies, having an automated QA system, making sure that we're not publishing complete nonsense, consolidation of data, which is then archived for then archived and in a different format. It is also stored for audit and QA, and other processes that involve, creating the layouts and coordinates for the map that we display, creating scales that we display for comparing different things, and having, things like refreshing the cache, which we use to speed up the page load on the website and things like that. But in the design of the service, which might be more interesting to some people, is also a very complicated process, and they involve it involves quite a bit of deliberation. So let's have a look at this graph. Can anyone in the chat, it would be useful, someone can check, tell me what is the issue with this graph? No, shout if you have an idea.
Weekly variation?
No, well that is, yes, but we're talking about design. So, but it is that, but we can address that with a rolling average and make it easier to see. But let's just move to the next slide. This is excluding England. Again, you could do that on the website. So England, the showing of England is not really the issue here. But again, have a look at this. Does this show anything that shouldn't be there? Okay, I'm going to the next one. Does this show? This is only Northern Ireland. Okay, so we are showing Northern Ireland in this graph as orange. And that is an issue because it is not sensitive to local culture. So cultural sensitivity is an important factor in the design of a service that of this nature. So instead, we've excluded green and yellow from our color palette entirely, and we're using other colors. So in this case, it is yellow, but they're the colors that might accidentally be used, which would be offensive to certain groups or not be culturally sensitive, have been excluded from the service. And conversely, we need to also take into account, whilst being sensitive to cultural sensitivities, we must also take into account practicality of the decisions and of the choices that we make. So it is also important for this graph to remain accessible so people can actually see things. So we needed to have contrasting colors that are accessible to people who may be colorblind, but at the same time, we needed to also be sensitive to different cultures. And that is why, that's one of the considerations we made. Another example would be this. So this is how this, so now it's changed slightly, but this is how we initially launched the number of vaccinations in the UK. So you can see that it says people vaccinated first dose. The fact that this is showing or this is saying that is not by accident. A whole lot of deliberation and discussion went into this before the decision was made. In that, we considered vaccines delivered, people vaccinated, vaccinations, people given first dose, vaccines, first dose. So each of these might be suitable. They all, you might think, say the same thing, but that's not necessarily the case, because you might have undefined dose. So that would be potentially misleading, or you might be giving false information because you're saying people vaccinated, and people looking at that would assume that these people are now immune, and they're not. So we can't just drop the dose. It has to be there. This is too verbose to be a headline figure. It's just too long. Or it might give, impression that people have been offered vaccination but not given the vaccine. So there are different considerations that have to go into each part of the service in terms of its design, in terms of its implementation, consistency, the way it's viewed on different devices, and things like that. And these take quite a bit of work to get right. And we don't always get it right. We try to. We do user research. We talk to people. We, ask people's opinion on social media. We do all this, and we still might not get it right, but at least we are trying to do that, and we are willing to change things when we don't get it right. And the only way we can do that is by engaging with people, so that if an issue arises, we could deal with it in a timely manner. The next important part is about accessibility of the service, which is often overlooked by a lot of people. Accessibility is not a one-size-fits-all thing. We shouldn't always try to tick boxes, use automated services to ensure that the service is accessible, or be, or try to be compliant with, government guidelines or GDS guidelines. That does not make a service accessible. That's a box ticking exercise. If you are trying to be inclusive, that is not the way to go about it. The way to go about it is to, communicate with people who actually have disability and make sure that they can benefit from the service, as opposed to assuming that we have made it useful to them. So we can take different measures, and we have taken different measures to make this service as accessible as we can make it. And it's an ongoing process. It's never done. We keep working on it. We keep making it better. And we keep listening to people. So, for instance, all graphics on the website have an alternative text associated with them, directing people to where they can see the data associated with that graphic. The headings and the content have correct labeling that might not be visible to people who use just normal displays to look at the data, but it is visible to screen readers that can read it. We also make sure that we don't only address visual impairment, because that's not the only disability. People have different types of disabilities. Some people might be sensitive to flashing images because they have epilepsy, or some people might be sensitive to things like running text, which is too wide. And these are considerations that we need to take into account when creating, again, a national service. Moving on to transparency. And why is it that we do what we are doing? And why is it that we have been doing it for months on end? And some of us haven't even taken a day off. We've been doing it on Christmas Day and New Year's Day. And what motivates us? What motivates us is basically, the Eye did an interview with us a couple of weeks ago. And this really sums it up. In that someone sitting at home in Newcastle sees the latest trends and graphs for the first time at 4 p.m. at the exact same moment as Boris Johnson in his office in Downing Street does. And that's actually true. Yes, the Prime Minister might be able to get the data, bits and pieces of data from here and there if they really need it, but they can't get all of it, and they can't get it in that format. So there are advantages and disadvantages, of course, to anything. And in this case, in my opinion, the advantages far exceed any disadvantage that we might have. And they're not necessarily mutually exclusive concepts, because it helps people understand government decisions. It makes data and information accessible to millions. It justifies decisions that are made, or restrictions that are imposed, improves trust in those decisions. And the fact that we just can't do everything. We can't possibly do all on our own. The disadvantages would be, there is room for misinterpretation. Some of the media have, done some very bizarre calculations that just make absolutely no sense to anyone. Adding one metric from one, background, say deaths from the National Statistics Institute to deaths within 28 days, adding them together and say we have 100,000 deaths, just makes no sense. There's a lot of pressure to publish as soon as you can, and there isn't really any room for any type of mistake, any room for any maneuver that we might need. We have very limited time to do QA, and we don't really have any room for delays. But there are two things here that are both advantages and disadvantages. One is rapid identification of mistakes, and the other is ever-growing demand for data. I mean, the moment we publish something, people start asking for something else. And we are constantly trying to source new metrics and new data to meet the demand. And that is not always an easy task. I'll get more into it in my concluding remarks, but yeah. And the rapid identification of mistakes is an advantage in that we can very quickly identify. I mean, there are 45 million daily records that are being pushed onto the service. There's zero possibility for us to be able to identify any and all mistakes. I mean, there are things that we can check, like headline metrics, but anything beyond that is just impossible for us to check. So it's an advantage that we have a million armchair specialists doing the QA for us, but it's also making things more difficult because we might end up on the front page of things we don't want to end up on. Next would be, so as I said, 100,000 viewers at 4 p.m. and our mistakes are broadcast on national television within 2 minutes of us making them. And so this particular example, we released the data at 4:04 on that Sunday, and this is the actual website being shown on the national news within 2-3 minutes of it having been released. And this brings with it a volume of work and a level of pressure that is not really something many people have experienced day after day after day. So rapid identification of mistakes, again, as I said, it has advantages and disadvantages in that a vast majority of users, like 99.9% of them, tell us about a possible problem, and they do so to help us fix it as soon as possible. There are a very small minority who try to catch us making mistakes to either ridicule our work or justify some unfounded theory, say the pandemic is a hoax or whatever. But at the end of the day, they're both our users, they're both equally important, and they both have the right to see the data and deserve to be heard. So they just go about it in different ways. We can look at it in a different way in that the points that they're making would inform the design and user research sessions that we run. So we can ask more relevant questions. They improve the robustness of our standard operating procedures in that we could probably add X and Y to our checklists. So we make sure that X or Y are correct, or if we have been doing that, we could look out for certain things that we weren't looking for before. So that improves our QA process, and we can improve our design to make sure that people do not misinterpret things or inform them better. As I said, we have ever-growing demand for data. Right now, we have 44 metrics currently active for deaths, just deaths in the UK. Of that 40 are active, 4 are under development, and 6 have been deprecated. So there used to be 50, now there are 6 have been deprecated, so there are 44 remaining. And that needs maintenance, that needs sourcing. So they all come from different sources. They have to be, so they're not always released on the same day. There's a whole lot of complexity associated with having so many different metrics and so many different, so much information about one thing. It also opens the doors to misinterpretation, because data might be delayed. So say we are trying to one of the metrics is deaths by death certificate. I mean, and people are complaining often, why are these data delayed by 2 weeks? Well, because it takes time for death certificates to be issued and then recorded in national statistics. That's just the nature of the data that we are releasing. Of course, majority of our users aren't specialists in these domains, so it's not really something with which they're familiar. However, this level of openness increases trust. So our trust level has increased quite noticeably since August. So we had about 63.4%, then increased to about 78.9%. And then in our latest survey in February, we reached 91%, if I'm not mistaken. And this is not only because of openness, it's partly a result of that. It's also associated with, us communicating with people, directly. We try to be approachable. We try to be nice to them. We try to, address their concerns and answer their questions, put a face essentially to an otherwise faceless service. And we're willing to change things. We're willing to reconsider decisions if there is a good reason to do so. And we are very willing to accept mistakes when they're made and take very, very rapid measures to rectify them. So there have been instances that someone pointed out a mistake in some data. We investigated the mistake, corrected it, and redeployed the data within 2 hours of them notifying us. We also can't do it all. It's impossible for us to do everything. It's impossible for the government to do everything. So having this level of openness would mean that people, institutions can collaborate and can make things happen and can produce things that we can't, or we don't have the time or resources to do. So these are examples of such collaborations, or if you like, the work that the public have done. So this is very interesting. So this is difference in our daily publication of cases by specimen date that's done by a member of the public. This is a daily changing the number of cases at MSOA level in an animated daily animation, which is not something really we can produce, because this is not you can't show this on a website unless you create a GIF animation or a movie out of it, and that's not really something you would show on a dashboard service. But it is nonetheless a useful information, and it is being produced by people who are very committed. They have been doing it all the way since I think June, every week, or sometimes even every day in some cases. It also promotes collaboration, as I said. So there are, the websites that have been created based on the data that we release every day. Again, people are maintaining websites. They include additional data in it if they need to from other places. It has news outlets, and they use the data to inform the public So Financial Times and Sky News have done excellent work with the data that we publish every day. International agencies like WHO use it to derive policy. Researchers use it to do studies, like from Imperial and Johns Hopkins and elsewhere. National organizations use it to obtain consolidated data for different purposes, so Joint Biosecurity Council, local authorities, police, but different organizations who regularly get the data from the service. And it also helps people make daily decisions in that, people decide to go to the barbershop to have a haircut on the basis of the data that they see on the website. They plan business activities. Someone told me a couple of weeks ago that they saw the rate of cases increasing in several regions, and predicted that there might be either a national lockdown coming or a local one. So they were running a national catering business, and they ordered smaller amount of stock so that they minimized the risk to their business, they minimized the loss to their business, and they even use it to plan their vacations, visit to family members and things like that. So it has material impact on people's daily activities. And we also have our entire code base available in public domain. It's entirely open source and available through 15 repositories. We have had collaborations on parts of our service from all over the world. It has been, reviewed to death, really, by people who are very good at what they do. And that also ensures that our service is always up to date, it's always compliant, it's always secure, and the transparency of it is also helping people trust the service. They know when you can't see the code base, that we're not, trying to run some malicious thing on your computer or something, some of these conspiracy theories associated with the government. We don't do that. You can see the code. It goes directly from there to our server and live on the web, on your screens. And in conclusion, really, how should we do it in the future? I mean, this is probably a bit premature at this point, but in part, one of the main challenges that we've been facing throughout this project since the beginning, it's been to source data from different organizations. So that's number one. And number two has been to reach agreement between different parties. And I'm not talking about politicians and political considerations at all. In fact, politicians have more often than not been fairly helpful in this. But there are people who may have legitimate points on how a specific metric needs to be calculated, and they disagree with each other. And that delays the release of data by sometimes months. It is utterly unacceptable to be in that situation in a pandemic, because it's more important, really, at least in my opinion, to do things fast than to do them nice. And that type of disagreement is not really helpful in this scenario. So there needs to be really a body that has a final say in such disagreements and can enforce that final say. So you might argue that the onus in part is responsible for national statistics, but the ONS cannot enforce things. And it's not always, it can't always be impartial, because part of the data that may be, the part of the data that we are presenting to the public is from the ONS. So if you have a stake in it, you can't really be impartial in it. Then, we need to have, defined measures to break ties in specialist domains. So was very good at what they do. The statisticians at the ONS may not necessarily be public health, specialists, or any other domain, bioinformatics specialists, whatever it is that we're talking about. Independence and impartiality, as I said, you can't have someone making decision who heads an organization, has a stake in what is being discussed. And we need expertise in handling large volumes of data, which is really missing across the board, in handling large volumes of data in real time and near real time, which is something we've been doing in this project, but we don't really see across the board. And we need domain specific expertise, in that you need to have people with expertise in different domains. In this case, it is public health, but it might be something to do, even with microbiology. It might be bioinformatics. It might be environmental. Whatever it is, you need people with domain expertise readily available to collaborate with such projects. And to achieve that, I think it might be justifiable to have an institute, a National Institute of Data Science or something along those lines, whose work would be to handle large volumes of data, deploy services such as this dashboard very quickly, have people with domain-specific expertise readily available, or be able to source them from different agencies and have them seconded to them, and be able to have the final say on certain matters and then enforce it. And that would make things run a lot more smoothly in the future. It would also help create more resilient services. It's just basically sheer luck that this dashboard is what it is today. It's because a few people were in the right place at the right time. They had different expertise, they collaborated together, and they created this service just by luck. So this, in the future, we can have we can have a body that is ready and able to deploy things as and when needed. And finally, a whole lot of people collaborated and helped us in this service, and it wouldn't have been possible without their help, particularly colleagues in PhD and current and former members of the team, the analysts whose names are rarely mentioned in different places. They are really unsung heroes of our service: NHS, DHSC, statistics organizations, DAs, and as well as Palantir, who helped us with the data, and Microsoft and Microsoft Azure support team, who have really been very extremely helpful to our service. Yeah, that's it. Thank you.